but they're closing the door, so we can start and steal 1 minute from your free time. Welcome, everybody. Today, we are going to speak about PowerPivot Excel 2013 in action. If this thing, okay, works. First of all, a few words about me, who I am. I am Alberto Ferrari. I'm a consultant at SQLBI.com. If you never visit SQLBI.com, go there. You will find a lot of the stuff I and Marco Russo write about analysis services, business intelligence. We do consultancies for large data warehouses or small and complex data warehouses. Sometimes we write books. There's a terrible echo. Okay, maybe this way it's better. Sometimes we write book. We are Microsoft BI Gold Partner, Maestro, MVP, MCP, and a lot of different names. But the real important thing for this session is that we really love to do business intelligence. We like business intelligence. We like playing with data. We like working with data and getting insights out of them. So first, before I start the session, I just want to have an idea, if I am able to look at hands raised, because I have 2 lights in my eyes and I don't see anything. How many of you are in the BI industry? Well, let's say half, not so many. How many of you with Microsoft BI Stack? Of course, same hands. I don't expect other people to be here. How many of you work with analysis services? Few less. You know what self-service BI is? Yeah. How many of you already tried PowerPivot for Excel 2013 or PowerPivot for Excel in general? Most of you. Wonderful. Have you already used DAX? Not so many. So you are using PowerPivot but not using DAX. That's a pity. Do you still want to hear about big data? So I'm sorry for you. This is not the right session. I think I heard enough about big data. And how many of you use Excel? That's interesting. All hands raised. And the reason why I used this last question, the first are just to understand who you are and what your knowledge is. The last one is just to see all the hands raised and to make you think about one simple fact. Everybody uses Excel. I guess Word and Excel are the most used software all around the world. Excel is really important. These things don't want to work. And to let you understand better why, try to think for a moment at what happened in the 70s. I felt really old when I started the title, What Happened in the 70s, because I was there. And it looks like a lot of time ago. But in the 70s, a lot of things happened. Woodstock, sexual revolution, music, a lot of interesting stuff. But of course, we are geeks, so we are not interested at all in music, sex, and anything like that. We are really interested in computers. And so what happened for computers in the 70s? If some of you looking at the screen sees his first computer, then it means you're at least old as me. If you see the second one, then you're much older than me. But the point is that in the 70s, if you search for pictures of computers in the 70s, you will find a lot of them on Bing. But in the 70s, we were focused about hardware. You can look at pictures there. You will find a lot of screens, ugly monitors, small keyboards, strange computers, but hardware was the keyword. Then in 1978, at the end of the 70s, something really changed the world. It was VisiCalc. Before VisiCalc, people entered in the shop saying, I want to buy a computer. Then, after that, people entered in shops saying, I want to buy a VisiCalc. And that really changed the way we work with computers. Because at that point, they did not care about hardware. They want VisiCalc and any hardware which is useful in order to work with it. Of course, VisiCalc was the first spreadsheet from there, a lot of road passed, and we created many interesting tools. We moved very far from there, but the beginning was VisiCalc. And VisiCalc is now, Excel is not nothing but the grandson of VisiCalc, and VisiCalc changed it. Now, in 2009, something similar, in my opinion, happened. Microsoft announced PowerPivot, and they shown PowerPivot during the past conference in 2009. Microsoft said to us, you need to be there because we are changing the world again. We are building a tool that will really change the rules. I was a BI professional. I guess I am BI professional right now, but I was a BI professional even then. And my first reaction was, come on, you are joking. That's not going to change anything. You cannot expect users to really adopt self-service BI. They will simply return to Excel hell, a lot of spreadsheet, nobody will understand data, and there's no way a user will be able to write its own data warehouse. And so this was my reaction. After that, I wrote 3 books about DAX, done a lot of courses, so I simply changed my mind as soon as I have seen what PowerPivot can do for business users. And this is what I want to do today. I want to speak about the DAX language, which is the programming language of Analysis Services 2012 Tabular, of PowerPivot for Excel 2012, and 2013, and Excel 2013 data model. They changed the name, but the foundation is always the same, the DAX language. A new language, new technology, new way of working with data. And if you already know SQL, you already know MDX, get ready to learn something completely new. DAX is not MDX, it's not SQL, it's a completely new language that requires you a greater effort in order to understand how it works and how to get the best out of it. If you are not still using DAX, I hope this session will give you some ideas and raise your curiosity about using the DAX language. So today, I'm not going to teach DAX. It's impossible to teach DAX in an hour. It will be just some simple formulas, not very useful. So what we will do, is simply look at DAX in Excel 2013 in action. What I'm going to do is take a very simple scenario, AdventureWorks, of course. They have a data warehouse. They come to us saying, I want to build reports out of this data. I want to create formulas. At the beginning, the formulas will be very simple, and then they will increase in their complexity. Don't spend too much time looking at the code and trying to understand it. I will simply write it, but you're not supposed to learn the DAX code. The important part is the flow of information, how we build a complete solution out of some simple tables and some DAX programming. I'm not sure all Excel users will be able to do the same, but I expect Excel power users, Excel gurus, and BI professionals to be able to do the same thing I will do today, just after a few days of study and nothing more. So the scenario is AdventureWorks. They sell bikes all around the world. They already have a data warehouse, so they have dimensional model containing facts and dimension, sales, data, orders, geographical location, and so on. But they are stopped. They only have the data warehouse, they don't have any reporting, and they need to build a solution. A classical solution they can build, we still have one slide here. They have the data warehouse containing date, customer, geography, categories, product, and sales. That's a very classical star schema, as Kimball taught. And these are the tables we are going to use. If they don't know about Excel, they don't know about Tabular, they just know about the good old analysis services, they probably need to hire a good BI professional who will start opening Visual Studio, creating the dimensional model, creating some MDX code, format everything, create hierarchies, do all the work, the technical work that need to be done in order to build a solution. So let's imagine that we have a good BI professional. We have Marco here, who is a good BI professional. So imagine that he starts writing right now the solution for AdventureWorks. In the meantime, while he's opening Visual Studio and preparing everything, we are simply going to prototype everything in Excel. And from this point on, I will just show a few slides, but most of the session will be just on demos. So we will open Excel and build everything from scratch. So I need to switch to the demo machine, and we start opening Excel. During this time, imagine we are users, we are not BI professional. While Marco is working with Visual Studio, we are working with Excel. So the tool users are able to understand. So we are not going to do anything too technical. And of course, since this session is on PowerPivot, the first thing we do is opening the PowerPivot window. From there, we need to load data from the data warehouse. This instance is called demo, so we connect with the demo machine, and we open the AdventureWorks Data Warehouse 2012. We select from a list of tables, and here, PowerPivot presents the list of all the tables that can be loaded. I'm not going to load data from tables just because AdventureWorks uses so many columns for each table. English product name, French product name, Spanish product name, whatever you want product name, and because Italian product name is missing. So I'm not going to use all this. I have created a very simple set of views that reduce the number of columns from the tables, so we don't have to look at all those columns, but choose only the ones we are interested in. So we want the calendar, categories, we want customers, of course, we want products, sales, and sales territory. Let's say we want 6 tables, and start loading data. This is the standard way of working in PowerPivot. First of all, you load data, and then you do something different on data. We have our data, it's loaded inside Excel, and here you can see we have calendar, categories, all the tables in our data model. First thing we need to do is set up some relationship. Being views, relationships are not detected automatically by the engine, so we need to do that by hand. It's a star schema, so once we have enough real estate, we put sales territory, products, categories there, calendar here, and customer here. Now, product points to product key, and then from product key we have somewhere a subcategory key that goes there. So we have sales, product, categories. This is not a real star schema. It's much more a snowflake schema. That's not a big problem. If we were to create better views, we would replace categories with a denormalized version in the data model, in the product table. But we are users. We don't know how to write SQL too much, so we just trust what is here. The order date goes to the calendar table, and somewhere we should have, yes, the customer key. Each sale is tied to a customer, and a customer lives in a specific sales territory. So we have created our data model. We have everything working fine. And at this point, without doing anything complex, we can start browsing some data. Remember, we are user. We don't know much about programming and all this complex stuff. So we simply create a pivot table. We take the calendar year, put on the columns, and from the sales, we should have sales amount somewhere. Sales amount goes there. And from the products, okay, here you are, we simply take the color and put it on the rows. So the pivot table is already working. And as simple as this demo is, think at the time you would need in analysis services to reach the same point. Normally it takes, let's say, half a day before you create hierarchies and you design everything. With PowerPivot, everything is much, much faster. You can do that with your customer data, starting immediately playing with data and showing him what a cube can do for him. But, of course, we computed sum of sales amount, then we can remove the column. For example, put the year here inside the calendar table, which I normally lose. We have the month name, put the month name on rows, and you can appreciate the way Microsoft thinks a day should be sorted. Of course, August is before December, but December is not really before July and November and October. So by default, PowerPivot uses sorting, alphabetical sorting for all the columns, including the date, and we need to do some cleanup. So we go on the calendar table, which is here, go to the month name, and we ask to sort it by another column, which is the month number. Now, month name is sorted by month number, and we go there. Now, July comes before August, and September, October, November, December, and so on. The pivot table is already working. It's computing sum of sales amount, and it's OK. We don't need to do anything more complex. Of course, since we have 2005, then month, and then probably the customer will want to use the full date here, we might be interested in creating the full date here. And the customer normally uses 2005, July, and then other column, the date. After that, we can simply create a hierarchy out of those. To create a hierarchy, we go to the diagram view, go to the calendar table, and from here we take the year and then the month name, full date, right-click, create a hierarchy. And again, the interesting part of this is the simplicity you can do with tabular. You don't need, when creating a hierarchy, to worry about natural hierarchies, unnatural hierarchies, technical stuff, in performance, and anything like that. The hierarchy is simply created as a list of columns. Then you can remove year, remove month name, remove full date. And if you reopen the calendar, now you see calendar, the hierarchy is here, and it immediately browses all the information. Now, we lost a few minutes. We created our first solution. It's working. And it is time to go to the customer and show to him the result of what we have done. Now, I don't know what happens to you with your customers, but I know what happens to me with my customers. Whenever I build something and I go to a customer showing the result of my hard work, the answer is always, yes, it looks like what I wanted, but not exactly what I wanted. So I ask them to be much more precise and say, OK, now you tell me exactly what you want. And the answer after all my hard work is normally, yes, you did what I asked. Now that I see what I wanted, I understand this is not what I want. I want to see something different than that. And that always happens. So, of course, we are here in the same situation. We go to AdventureWorks, we show him the result, and they say, oh, you show me sales amount, now I want to do something different. I don't want just sales because now business is moving. We want to do different calculations. And what I want to see is the number of customers I have. That's not a big problem. In analysis services, you can solve this pretty easily. But what you need to do is first explain to the customer that dim customer is a dimension. They don't understand what a dimension is, so you need to speak and explain some of Kimball theory. And then what you need to do in analysis services is create a new measure group based on dim customer, create a new aggregation, which is a count over the customer, over the dim customer, and then you do your work. But in analysis services, that means, let's say, a couple of hours of work. And you need to open the solution, check it, create the views, check that everything works fine, debug it, and make it work. In the meantime, while everything is happening there, we do the counting of customer here, which is not very hard. In order to do the customer count, what we need to do is create a new measure, create a calculation that counts the number of customers, which is not very hard. You go to calculated field and create a new calculated field. We don't want to tie it to the calendar, but we put it on the customer table. And it is customer count. Can you read it from the bottom? Say yes or no so I understand it. OK. From the bottom, I say not asking to you. OK. What we want to do is counting the number of customers. There is a beautiful function, count rows, that, as you might imagine, simply counts the number of rows in a table. We simply do count rows of customers. And then once we have the formula, we have created as a calculated field inside the customer table. We know it's a number. It's not a decimal number. It's a whole number with 1,000 separators, so we format the formula correctly. We simply click on OK. And the first result is not very nice. We see the same number for all the customers. But we are BI professional. We know that this is correct. So we remove the calendar from here. And to debug our formula, we simply take, for example, the gender, put it here. And now we see that it is sliced half and half. So the formula is working. And what we do is demonstrating the correctness of the formula just by looking at a number and say, yes, half and half looks reasonable, so the formula is correct. We can go then to the customer and show the formula to him. We have sales amount, customer count, a couple of minutes, and the customer is happy. What happens is that I go to the customer, show him the number, and say, whoa, that is really interesting. So let me play with this. You put the gender. I'm not really interested in looking at the gender here. What I want to do is put the calendar and see that. And say, oh, well, that's a problem. You asked me to count the customers. Of course, customers cannot be sliced by date, because a customer is a customer. I'm counting the customer which are male or female, not counting the customer that you have during time. And so what we discover at this point is that the customer says, oh, probably I did not explain it very well. What I wanted to count is not the customers that I have. I want to count the buying customers, the number of customers that day by day enter my shop and want to buy something from me. And at this point, I start to be scared, because that means we need to do a distinct count over the fact table. For the ones of you working with analysis services, you know that distinct count is a pain, is a real pain. You need to do a lot of work. You need to put the customer key inside the fact table, build a new measure group, run everything. The measure group need to be separated by the original one, and then you need to do a lot of work in order to make it work. Moreover, with AdventureWorks, speed is incredibly fast, but as soon as you start to have hundreds of millions of rows, distinct counts are amazingly slow, and optimizing them takes a lot of time. It is one of the things that I normally find it really hard to explain to my customers, how hard it is to build something that, from their point of view, is indeed very simple. But hey, this is something from the past. We don't want to worry about what happened in multidimensional. We are now with PowerPivot, and we simply play with our DAX code. We use the count rows. Count rows is nice, but it's not the formula we wanted to use. So what we need to do is simply go to our calculated field, and instead of doing a simple count rows of the customer, we change our formula. That now should be something different. What we want to do is the distinct count of sales customer key. And this is all what we need to do. We simply count the number of, not currency key, thank you. Not currency, but customer key. Let's check it, no errors in formula. Again, it's a whole number, we don't want decimal places, and now this customer count perfectly works. It is filtering by data in a very simple way. And we did not have, this is the most important thing, I start to tell you now, look at it during all the demo. We don't have to modify the original data model. The data model contains sales, contains customers. We don't need to modify anything in the data model in order to get much more interesting calculation. The point in tabular is always working with DAX. Much less work in the data model, a lot of work in the DAX in order to write good DAX. This is very important because, first of all, it's easier to build prototypes, proof of concept, and work on scenarios to demonstrate to the customer what you are going to compute. And moreover, whenever you touch the data model, that means writing ETL code. And in a solution, in a business solution, ETL is by far the most expensive part of the complete solution. If you can cut it, then life is much better for everybody. Anyway, I guess the customer should be happy. We have been able to compute the sales amount, which is nice. We have computed the customer count, which is the number of customers. And again, we go back to the customer, showing him the result of our hard work. And at this point, the customer is really happy, says, whoa, that's what I wanted. But look what, the numbers are wrong. You counted the customer key, which looks fine, but the customer key is not the number I wanted. Customer is a slowly changing dimension type 2, so the customer changes his key during time, but it's not two times the same customer. It's always the same customer. And I want you to do the distinct count, not of the customer key, but of the customer code, which is another column in another place. This really scares, because in order to solve it in multidimensional, what you need to do is take the customer code and push it inside the fact table through some view, which is incredibly expensive, and then do the distinct count over that, paying, by the way, an order by on the fact table by the customer code, which you can do whatever you want, but it will be really, really hard whenever you process your cube. Again, we are not using multidimensional, we are using tabular. So what we do is modify our code and say, yes, what you want to do is not computing the customer count, the number of customer key. You want to compute the distinct count of the customer code for only the codes that exist inside my fact table. And so you just modify again your code. And instead of writing distinct count of customer key, you need to start writing some slightly more complex DAX code, but not really too complex. Now let's start from scratch. It's easier. What you need to do is compute the distinct count of customers. I always forget to put the customer code, so let's put, for example, the customer name. That is fine. So we are not computing distinct count of customer code, we compute the distinct count of customer name, but the technique is absolutely the same for only the rows that exist in the sales table. Check the formula, it works, we click on OK, and now the numbers are different. This is the distinct count, not of the customer key, which might be wrong, but it's the distinct count of the customer name. It's interesting that without changing the data model, you can compute the distinct count of names, codes, vendors, categories, whatever you want. Any distinct count on any dimension can be easily computed using a very simple pattern, 3 lines of DAX code, which is not very easy to understand. It takes some time to learn it. But once you learn it, as you probably know SQL, as you probably know Excel, as you probably know a lot of different languages you use in your daily work, that will be very easy to do. And a few lines of code, and the distinct count of this is done without having to do anything on the data model again. Let's go to the customer again. Now we fixed it. He knows he should not ask any other distinct count. And now, because customers have problems, you say, while you are here, I say, this is cool, you have been able to solve all of my problems. Now I would like to see something different. I want to know how many customers I have in any period. I want a slightly different calculation, which is the number of new customers that enter my shop that I have in any period. Now, a very quick question for you. How many of you know how to solve the new customer scenario with multidimensional without going to Bing? Nobody. And I didn't raise my hand either, because this is one of the classical scenarios where I need to solve the problem. I go to open one of the book I wrote, read the solution, and then implement it, because I don't remember it. It's pretty normal. In DAX, there are solutions to this, and the solution, while not absolutely easy to do, it's not either too much complicated. So we move back to the demo machine again, and now we try to compute the new customers using DAX, trying to follow the flow of the formula and understand how it works. So we go here, calculated field, and create a new calculated field. This time, I will need slightly more space. How do you compute new customers? A new customer, the definition of a new customer is indeed very easy. A new customer is, first of all, a customer. Being a customer means he is buying something in the current period. But these are just customers, the number of customers. We already computed it. In order to be sure that it is new, we need to check that he is a customer today, and he has never been a customer before. So he never bought anything before, and he is buying something from us today. And so with this idea in mind, we can start writing some DAX. All interesting DAX formula start with calculate, so we start it this way. What we want to do is count the number of customers. So we count rows of customers. But we don't want to count all the customers. We want to filter them. So we filter the customers. And we want to see, out of the complete customer table, only the ones who bought something in the current period. In order to translate bought something in the current period in DAX, we need to check if there are rows in the sales table for the current period and for the current customers. If there is a sale, then it means the customer bought something. So this translates into DAX into another calculate, which is count rows of sales. This calculate count row sales simply computes the number of rows in the sales table for this customer and in the current period. Of course, the current period will happen in the pivot table. Right now, the formula only filters the customers. And this number should be greater than 0, meaning that there are some sales for the current period. But we know this is not enough, because this would compute only the customers who are buying something now. We want something more complex, and this something more complex is that the customer never bought anything before. So it's another calculator. Again, we check the number of rows in the sales table, but this time we don't check the rows in the sales table for the current period. What we want to state is that the customer never bought anything before. To say before, we change the filter inside on the date table, and we say, okay, instead of looking at the current period, filter all the calendar, showing only the rows where calendar full date is less than mean of calendar full date. Where are you? Okay, this DAX is not very easy, of course. I hope we closed all the parentheses correctly. This DAX is not very easy, but it's not too much complex. Think, for example, at the average SQL query you normally write during your daily work. It's much more complex than this. It contains queries, subqueries, where joins, and a lot of complex relationships. So while you might look at DAX and don't understand it at first glance, this is just a temporary problem. As soon as you learn it and you start using it, you will write it exactly at the same speed as I write it. I remember the flow of this formula. Of course, I don't remember exactly how to write it each time. But once you remember how DAX works, you simply write it at this speed. And you are able to solve this if the formula works. Whoa, I wouldn't expect it. This is the number of new customers. So we put in the customers, and we call this formula new customers. Again, it's a number, it's a whole number, 1000 separator. We click on OK. And it seems it's not working. No new customers here. That's not correct, of course. No, should be, oh, I use it min, max, I don't remember. New customers, edit. Calendar full date. All right, equal to 0. I forgot to say that all these calculations, calculate, count rows, sales, blah, 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 should be equal to 0. This equal to 0 means compute the number of sales in the current period, and that should be greater than 0. And then compute the number of sales in the periods before, and that should be equal to 0. Otherwise, that means it might have bought something before. Let's check it again. Let's click on OK. Let's cross our finger. Now it's working. You see, at the beginning, all the customers are new customers, but after some time passes by, and the number of new customers is smaller than the number of returning customers. Again, it is important to know the difference between tabular and multidimensional from this point of view. Nobody knows the solution of new customer in analysis services because it requires advanced modeling technique. Using DAX, it's just a matter of writing some DAX code, nothing else. The data model is the same. You don't need to learn anything complex. You just write some DAX code, and our customer should be happy. By the way, one of the interesting part of this expression is that new customer, as it is now, it is able to compute, sorry, here it is, the number of new customers. But you are able to solve, using DAX, much more complex expression. Imagine that the customer at this point asks you, hey, this is cool, now I want to see the sales amount coming from new customers because I want to compare it with the sales amount coming from returning customers because I'm doing some advertising and I want to understand the impact on my sales of this sales amount. I have never written how to solve this in multidimensional. It's really complex. If you want to do that in DAX, that's not very complex. You simply create a new calculated column, which is sales of new customers. And what you need to do is simply modify, of course, your DAX code, which this time doesn't do the count of customers, but computes sum of sales amount, using the very same filter you have seen before. So this filter filters only the new customer, and this time you compute the sum of the sales. Of course, it is a number. This time is a decimal number. We want that we compute it, and we put it inside the pivot table. And now we have, you see, this, in the last row, July, we had $50,000 of sales. Of those 50,000, 29 were coming from new customers. The rest were coming from returning customers. And so it's very easy once you learn how to write a formula to play with it and create complex expression, much more complex than what you can normally do by using data modeling in multidimensional. But we are not yet finished. We have computed customers. Now, our customer says, that is nice. I have seen how to solve this scenario. I want to do now slightly more complex analysis because I use my pivot table. Let's go to the demo. Using my pivot table, I remove the calendar from here. I remove everything, just keep sum of sales amount, remove the calendar. I want to slice data by product cost, so I take the cost, put it on the rows, and the result is not very easy to read. It's nearly impossible to read. I am able to slice data by product price, but it's useless to do that. What I want to do is group, let's say, these rows in a single row, which is low price, then this row in a different one, which is medium price, and so on. and the customer asks for it. If you want to do that in multidimensional, again, that means creating a dimension, creating a relationship, modifying the fact table, and do some job in order to solve it. In tabular, this is slightly easier to do. What we need to do is, first of all, find a configuration table containing the price band I want to use. So I reopen the connection, and guess what? We have a price band table, which is here. We load it inside the data model. And the price band table is here. It contains the price band, a code, the price band from value to value. So any price from 0 to 5 will be very low, from 5 to 20 will be low, and so on. This is the configuration we use for the banding. Then we go to the diagram view, and we are in trouble because we try to create a relationship between the sales table and the price band table, and you will soon discover that there is no code, no key. There is no way to create a relationship between the sales table and the price band table. Again, DAX is going to help us. We go to the sales table, go to data view, and we use a calculated column. A calculated column is a column which is computed during process time, and inside this calculated column, we will mimic in some way the relationship between the price band and the sales table. As usual, we start with calculate, and we want to get the values of the price band name. I hate IntelliSense here. And we don't want all the prices of the price band. We want to filter the price band table, searching for the only row where the price band from value is less or equal than the current value of sales, which is unit price, and the price band's to value is greater than unit price. Louder. Price bands. Thanks. Okay. If everything is working, yep, we have our calculated column, which is here, and computes for each row of the fact table the price band. Of course, we rename it. It is the price band name. And everything is done. We go back to Excel. We remove the cost, go to the sales table, and near the end, we should have our price band name. Put it here, and now we have our separation done in this way. Of course, if you still want, you can take the unit price, put it there, and you see the prices which are in different positions. Data is not sorted correctly. High, low, medium, very high, very low. Either you use a prefix there, or you compute the price band code in fact table, you sort by column as we did with the date, and you're done solving the solution. Again, using DAX without having to rely on any DAX code or any complex expression or any complex data modeling. Just write some interesting DAX code. That is cool. We have been able to solve banding pretty easily without doing anything complex. The customer is happy. Customer happy means he's going to buy something else. And next topic that our customer wants to solve is ABC analysis. ABC analysis is a clustering technique that divides products into the most important product, class A, which are the ones which are responsible for 70% of my sales. Then class B are the less important product, the remaining 20%, and product in class C are the ones that produce only 10% of my complete sales. So the idea of ABC analysis is that it's important to focus on your core business. Product in class A are the ones that let you gain more. And so it is important to clearly identify the class of a product in order to focus on your business and avoid wasting your time on customers or products or whatever category you're analyzing with ABC analysis, which is not generating money for your business. Now, the users want to use ABC analysis to build reports like the one you see on your screen. A, B, C should be put on the rows or on the columns in order to analyze, for example, in this report, for each customer, whether he buys a lot of product in class A, B, or C. That basically means that the ABC class needs to be computed before the cube is processed. It needs to be an attribute of a dimension. It's not a dynamic calculation. It's a calculation that needs to be static, and it is used then to slice data. And users normally do ABC analysis using Excel. What they do is take all the products, sort them by price, then compute, sort by them by, sorry, not by price, but by total sold. Total sold is the total sold by each product. And once they have this Excel table, they compute the incremental total sold, which is simply the previous rows plus the total sold of the current row. I have it. Incremental is simply the previous row plus the current row. The grand total is the grand total of all total sold, and it is there only to simplify the formula. Then incremental percentage is the percentage of sales that this product and all the products before it generated. Once you have a table like this, computing ABC cluster is very, very easy, because until this number reaches 70, you are in class A. When you exceed 70, it means that 70% of the sales are in the products above, and the ones below are less than the 70%. So you use 7, 9 in order to divide your cluster and compute everything. That is Excel. It's not analysis services. If you were to do that in analysis services, you can choose to solve it using SQL. You first create a temporary table containing sum of amount grouped by product, build everything in a temporary table. Then you update your temporary table in order to compute the running total percentage, which is not very easy. In SQL Server 2012, you have windowing function that make this query slightly easy to do. But if you try to do that in 2008 R2, it's really a pain. Then you update everything. The major drawback of this solution is that in order to use it, you need to put some business logic inside the ETL part, which is not very nice. You need to compute values during ETL and then use them to drive attributes of your dimension. And moreover, you probably are going to create a slow ETL. This is not very fast to compute. So I did that for a customer a few years ago, and I used a different technique. Since computing the class of a product is very easy, not the class, but compute the set of products which are in class A, B, or C, it's pretty easy in MDX. What I did is a different thing. I processed the sales cube without the ABC class. Then using an MDX query on the sales cube, I grabbed the products in class A, B, and C. And then with this information, I updated the SQL table and reprocessed only the product dimension. So I got the best out of the two worlds, SQL and MDX. But it was not easy to build. It took some time to create the solution, build it, schedule it, and make everything work. So while this is what we should do in multidimensional to solve the problem, again, we move to the demo machine, and we solve the ABC clustering technique by using simple DAX. What we are going to use is simply calculated columns, nothing more complex than those. Calculated columns are, in my opinion, the most important modeling tool available in Tabular, because they let you create complex calculations, some sort of ETL, during the process of analysis. First of all, for each product, following the Excel example, we need to have the total sold. So we calculate the sum of sales amount, and we create a calculated column in the product table containing the sales. It seems empty, but in reality there are numbers there. It's just that a lot of products don't sell anything. So we sorted by largest to smallest so that we see some number. And we rename this column as total sold. Then we need another column, which is the incremental total sold. That is the total sold of this product and all the product that sold more than him. Again, this is not very complex. What you need to do is compute to check all the products and find the ones that sold more than the current one. So you need to get the price, the products where the total sold is greater or equal than the current total sold. Products total sold. And once you have found these products, you sum the products total sold. Okay, this expression computes the incremental total sold. Since data is sorted here, you see that it works. For each row, it contains the sum of the rows that happen to be before it. And it's a calculated column, so it is computed during process time, running total sold. And it's not computing at query time. Once you have this column, the rest of the job is very, very easy. You simply compute running total sold divided by the sum of total sold, that is the grand total of sales. And this returns a number which is not very meaningful in this way, but since it is, the running total sold divided by the sum total sold, it is in reality a percentage, so we format it as we want. And this is the percentage of sales that this product plus all the ones that sold more than it produced. It is exactly the column you have seen before. Rename it our running percentage. And finally, you compute the last column, which is the ABC class, where you simply check if running percentage is less or equal 0.7, then you are in class B. Otherwise, if running percentage, if running percentage is less or equal 0.9, then you know we are in class B. Otherwise, we are in class C. Let's hope. Okay, computed. You see we are in class A here, then starts class B, and then we have class C for all the products that sold not enough. We rename the column, and once it's done, we go back to Excel, we remove the price band name, and on the product table, we have our ABC class. Put the ABC class here, it's a column, it can be used to slice whatever you want. Again, the important part is that we somewhat simulated ETL using calculated column and computing complex expression inside the DAX code. ABC class is one of the kind of request that when a user wants, knows he has to pay a lot of money because it takes a lot of time to build the complete solution. But at this point, one can say, yes, that was nice, but not very easy. The DAX code was not really simple. You say that Excel is simple, but this is slightly too complex to be solved by a normal users. And so I want to show you in a few minutes just how you can leverage just Excel to solve the same scenario using slightly easier formula. Since we want to solve the problem in Excel, what we need to do is create a query where we take the products and we put them inside Excel, so that we can start working with it. So we connect to the product table, we grab it, and put it inside the table here. Now we have the product table coming from the Excel data model inside our Excel workbook. We go to Table, Edit DAX, and while this functionality is very well hidden, it is indeed very powerful because we can write here some DAX code, and this DAX code will let us work inside Excel with data coming from DAX. What we need to do is take for each product, we take the products, and for each product we want, no, sorry, yes, summarize products by products, product key, and we want to have a column which is called sales, total sales, which is computed as sum of sales amount. Writing this expression is really scaring during a session because you have no way to check that it really works. But it seems we got it working. We have some column here and some value. And we have the product key, which is the number we want to use, we will need to use. The table is not correctly sorted, so we go again to table, edit DAX, and we sort it correctly. And we say, okay, we want order by products, product key. No, sorry, order by sales. Descending. Okay, table, edit DAX, total sales. Okay, now we have our number and everything is here. Now, what we need to do is start playing with Excel. First of all, we want the running sales. And this time we are in Excel. We are no longer inside DAX, so we don't need to learn anything complex. In order to compute the total sales, you need to compute, to check the previous row plus the current one. Since the previous row for the header contains a number, you check if is number. We are in E5, so E4, then take E4 plus D5. Otherwise, take D5. If I'm lucky enough, yep, we got the formula working. And this is just Excel, nothing more complex. Now that we have it, we have running sales, and we can compute running sales divided by sum of total sales. Okay, I love Excel syntax. I have never been able to learn the syntax of table handling. Anyway, we have our percentage, and everything here is just Excel. This is the running percentage. And the final column we need to get is insert table to the right, our if. If running percentage less or equal 0.9, then it means we are in class A. No. Greater or equal 0.9, then we are in class A. Otherwise, if it is greater or equal 0.7, then we are in class B. Otherwise, we are in class C. What's the problem? If I can see it. If running percentage greater than A. Here? Yeah, but if I put that here, the syntax is not going to be correct. Huh? Okay, that is what I wanted to know. There is still a missing parenthesis. 1, 2, no. Okay, let's start again. Equal. If. I think it's much more stupid than this, and it's just the space between if and the parentheses. If running percentage less than or equal 0.7, then we are in class I hate that. 0.7, let me write it, I know, greater than 0.9, then we are in class A. Otherwise, if this is greater than 0.7, then we are in class B. Otherwise, we are in class C. One, close. It works. It's wrong, but it works. Because it's computing exactly the opposite. So, you know, I'm a BI pro, and I do C, B, A. And now it works. We have our ABC class. And this is ABC class. Because at the end, the point was not that formula. What I want to show you is that now that we have a table, we can go to PowerPivot, add the data to the data model, and this table, which is computed by a DAX expression and then recomputed by Excel in order to compute other formulas, can be thrown inside the data model again. We go to the diagram view, we create a relationship between the product key and the product key there. And now you can use attributes from this table in order to slice data. So we have ABC class. We can go back to our pivot table, which is here, remove this ABC class. We have our table. Of course, the name is not very smart, but this is not very important. Put the ABC class, and now we are slicing by using columns computed in Excel. And this is incredibly powerful, even because Excel is able to manage all the refresh by itself. If you refresh the data model, Excel will refresh the original data model, reload the data in Excel, recompute everything, and then push the data back in the data model and run another computation step inside the data model in order to grab all the information. That opens very complex scenarios where you can do part of the calculation in Excel, then let the user compute other values using Excel by itself, and then you load data. Think at budgeting, think at any kind of information you might want to push starting from the data model and then modifying them in Excel again. Let's go back to our slide. And the final point that I want to show you, I'm not going to spend a lot of time on this just because there are a lot of very, very cool demos about how to use Power View. But the point is that customers normally say, hey, I see that everybody has maps. They all see data on maps. Moreover, this period maps and big data looks, whoa, everybody wants to see them. And I want map too. If you are in multidimensional, you need to start thinking about how to solve the problem. That means, well, the map looks really cool, but in order to compute something out of this map, I need latitude and longitude, and then I need to understand how to search for the latitude of a single country or of a town. Maybe I need to use the geography data type in SQL. I found a way to use the geography data type. This is cool work. And once you have computed all this geography, you need to show data on a map, which probably require you to search on Bing for some kind of tool which is able to report data there. But again, all this happened in multidimensional. In tabular, just because we are so strictly tied to Excel, Excel has Power View, and Power View has very powerful tools in order to solve the problem of drawing over a map. We have sum of sales amount, which is here, and in order to create our map, that means to let our user create the map, we simply go to the insert, and we create a new PowerView report. Wait some time before PowerView opens the report, and we have our blank canvas here. Now we have sales territory. We can take, for example, the country. I said take the country. OK, and we have the country here. Then we want to get out of the sales, the sum of sales amount, which should be somewhere. Here it is. Now we have a country, we have sales, and all we need to do in order to transform it into a map is click on Map. What happens behind the scenes is that PowerView analyzes the information inside the tables, needs to do geographical resolution, so to find where each point is in the area. So takes this data, sends them to Bing over the web. Bing provides geographical resolution, that is, transforms each name into a point in space, and then grabs out of Bing the map and show everything here. So you can, of course, zoom on Germany and use all the tools you might expect to have in a normal map using PowerView. The interesting part, what I think is the really cool part of using maps, and generally speaking, using PowerView with this data model, is that it's amazingly easy. You don't need nothing at all. All what you need is an internet connection, because, of course, you need to connect to Bing in order to have geographical resolution, and then you need, again, to be on the web in order to grab the map and analyze information. But it simply works and does not need anything complex, anything special. Now, the point is that just by using this map, of course, this is a PowerView report. So I guess there are some sessions about PowerView, or you can look at a lot of interesting demos. But you can, for example, take your ABC class, which is, let's grab that, of table products. For example, you can take the ABC class, put it here, transform this into a slicer, and then once you click on A, you only see data coming from product in class A, class B, or class C. Or you can transform the same in, you can transform that. I lost where, oh, design. OK, I don't want it to see that as a slicer. I want to remove the slicer from here, but it seems there is no way to remove slicer from, oh, I want to see that, OK, as a table, and then transform it, adding the total sales as a map. So we add the sales amount for each class, put it there, transform it to the bar chart. And then by clicking on the class, you see both here and the different values on the map. Now, as I told you, I don't want to spend time on PowerView just because there are a lot of demos on PowerView. It's more than 1.5 years it's around, and there are a lot of interesting tools. My main goal was in showing DAX and the power of DAX in order to solve pretty complex solution in tabular. So, time to go to some conclusion. What have we seen? Basically, what we have seen is that tabular, I say tabular, but whenever I say tabular, I really mean tabular, PowerPivot for Excel, PowerPivot for, or PowerPivot for SharePoint. They all share the same code and the same user interface, the same engine. Tabular is a simple tool. It's not a simple tool. Tabular uses simple data modeling. In order to work with tabular, in order to work with DAX, you need to forget about dimension, forget about fact table, just think of tables, relationships, and DAX. DAX is the key to solve most, if not all, the scenarios, no matter how complex they are, in a classical BI solution for one customer. Its speed in doing calculation is incredible. The power of calculated column as a data modeling tool lets you provide some kind of ETL inside your solution, which is just local to the solution. And most important, when you go to a customer and you start working with him, you don't need to build, you don't need much time to build a prototype, and most important, you don't need to use Visual Studio to build a prototype. If I'm speaking with a customer and he says, I want to see this number, I open Visual Studio, I start doing techie stuff, then he probably goes away because he does not understand what I'm doing. If I do the same prototype just by using plain Excel, then the customer is still with me. We speak together, we build together a solution, we look at numbers, and I'm not doing anything he does not understand. So it's a different way of working with the customer. You're working with him instead of staying away from him working in your office. And finally, once this PowerPivot workbook is finished, you can simply open it with Visual Studio later when you are in your office, open with Visual Studio and transform it into a fully working tabular model without having to work on anything. It will simply work out of the box. You deploy on the server, and then you add security, partitioning, and all the stuff that need to be done in order to transform it into a complex corporate data model. But you don't need to do anything complex and anything strange. The only thing you really need to do is learn the DAX language, of course, which, believe me, it's not easy. Don't expect it to be easy. Don't expect it to be something that you learn in a couple of days. It takes some months before you are confident with the DAX language. More or less the same time you had to use when you probably learned SQL some years ago when you started working with BI or whatever work you are doing. So DAX requires some time and requires some energy. But at the end, the idea is that by using DAX, you will be able to what is happening is that using DAX, users will be able to write formulas. The formulas I have written are not so complex. They look complex, but they are not in reality. A user, an advanced user, will be able to write them and solve these kind of problems by itself, of course, with some help from BI professional. That is all what I wanted to show you. So we still have a few minutes for questions, if you have. Yes?
Would you say that DAX is easier to learn than MDX, about the same, more difficult?
OK, I need to repeat the question for the recording. And the question is, would you say that DAX is easier than MDX or more or less the same? I think the answer is very easy. If you work with MDX after, let's say, 5 years of working with MDX, you are just a beginner. Working with DAX, in a couple of months, you move from beginner to master. So the difference is really heavy. MDX is really complex. While DAX looks simple, it is not so simple as simple as it looks, but it's far from being complicated. It's a language that you can use and has been designed for user, not only for professionals, so it's much, much easier. OK? I don't see, so if you have questions, just start speaking, because I have 2 lights in front of my face, and I don't see anything in the audience. Yes? I don't hear you, sorry. There is a microphone somewhere there in the middle, so maybe you can come and speak there because I don't hear it. No, now I can hear, then I can repeat.
I've heard the criticism that the tabular model compared to the dimensional is immature and limited. Can you speak to that?
OK, so the question is if tabular is immature if compared to multidimensional. And I would say no, it's not immature. It doesn't have, tabular does not have all the features of multidimensional. That means it doesn't have natively parent-child, it doesn't have natively many-to-many, it doesn't have translations, it does not have all the features of multidimensional. But most of them can be simply solved with DAX. So most of the features which are missing can be simply solved using DAX. There are some features, namely complex aggregation, the presence of MDX script, complex scope of statements, or translations which are simply missing and not present. But there are not so many. So I would not say that it is immature. It's not complete. It doesn't contain all the features of multidimensional. And on the other hand, it has many features which are so faster than multidimensional that we have them in multidimensional and we don't use them because they are too slow, while in tabular they work fine. Distinct count, for example, you have seen they are amazingly easy to write and they are amazingly fast. They work more or less at the same speed as any other measure, any other calculation. So depending on the size of your cube, on the shape of the cube, on the kind of feature you use, it might be useful to think about moving to tabular or getting still to multidimensional. But I would not say that it's immature. It's just different. The two probably will live for a long time together because tabular need to stay in memory, multidimensional not. So there are differences between the two. And tabular does not cover all the features of multidimensional. On the other hand, multidimensional does not cover all the features of tabular. They are simply side by side, and they work in different environments and different scenarios.
I have a question about the calculation of the ABC classes. The reason I'm asking the question is because I'm not entirely sure if I understand correctly how DAX calculated it, but it seemed to me that by differently sorting that product list, your products would have ended up in a different class.
Oh, no.
But maybe I'm misunderstanding how DAX works. That's why I'm asking the question.
You're right. I simply did not spend much time explaining the formulas, but the idea is that the formula I wrote do not use the sorting. Then in the pivot table window, I use sorting in order to see data and understand whether the data was correct or not. But in reality, the formula did not use sorting. They simply filter a table, finding only the rows which have a price total sold higher than the current one. It's not tied to sorting, even because, as in SQL, tabular does not define sorting. There is no sorting of the table.
Okay.
And if you want sorting, you need to specify it.
And when you solved it with the Excel-only version, where you created a second table, wouldn't the sorting have affected
in Excel, we needed to use sorting
because
using Excel, I simply used the previous row, and so the formula I have written are dependent on sorting.
Okay.
So there are two different ways of sorting, of solving the same scenario.
Thank you.
Welcome.
Is there a best practice on that, whether you should use Excel versus DAX?
It really depends from so many. Oh, sorry. There are best practices between using DAX or using Excel. If you go to multidimensional, to analysis services tabular, of course, you cannot use Excel. You need to use DAX, and that's your only option. If you're working with Excel, I wouldn't say that there are best practices. If you know how to solve it in DAX, probably DAX is slightly faster and provides better both performance and handling during time. But of course, there are a lot of scenarios where using DAX is too hard, or maybe you don't know DAX enough to solve a scenario, and so going back to Excel is a good option. I think it's interesting to have the option to do that. I don't expect BI professional to use Excel, of course, to solve this kind of solution. We have better options. But from the user point of view, having the ability to use Excel, it's very welcome, because they can use their tool to make any kind of complex calculation and then push back the result in tabular. Okay. Thank you very much for attending. I'm missing. Okay. There are a few sessions you might be interested in looking at, again, speaking about DAX, Data Explorer, and this tool. You can find me later at Microsoft Booth tomorrow. Today, there will be a book signing at O'Reilly at 2:45. Or if you just want to speak about DAX, stop me whenever you